Here's a fun AI-powered microbit project. This project simulates a crosswalk with a pedestrian barrier and a traffic light. We are using the XYZ accelerometer values of the microbit and a trained Create AI model to determine whether or not the crossing guard is raising the stop sign and then opening up the pedestrian barrier and changing the traffic light so pedestrians can cross safely. To start, we're creating this miniature stop sign and then this pedestrian barrier. These are obviously totally optional, but just help to enhance the project. Next, we'll hook up our microbit, which is attached to our charge battery pack. You will need some sort of battery pack to power your microbit throughout this project. We've paired the microbit to the Create AI program. It connects wirelessly via Bluetooth, and then we're going to start by recording our samples. To record our samples of this action, we'll record 10 or more actions of raising and lowering the stop sign. Next up, we will record a series of resting positions, so this will just give the machine learning model something to compare to, so it can look and see whether the stop sign is raised or we're just in that resting position. Once all the sample data has been recorded, we will go ahead and train this model. Now that it's trained, we can test out our model by performing our actions and seeing the percentage of certainty for each action. Now it's time to build out our crossing station. To do this, we're going to use a series of other hardware pieces from Forward Education. We're going to use a positional servo motor to be able to control the movement of the barrier. We're using our smart soldering kit, which has 3 LEDs, which will simulate our traffic light, and a breakout board to connect all of these components together. Here we're just using some yellow electrical tape to create additional stripes for our barrier, and then using that same electrical tape and a few other pieces to attach this barrier to our positional servo motor. Now we need to add in a second microbit, which is going to control this crossing station. Before we do that though, we need to update the code on our original microbit to add a radio signal. We want to send a specific radio signal for each one of our actions. We'll download this new code, and then our first microbit is all ready. Now we'll hook up the second microbit, which will be the receiving microbit and the one that's controlling the crossing station. Start a new project for this, and then you will need to add the Forward EDU extension. This is what will allow you to program both the servo motor and the traffic light in this project. Here we're just controlling the servo motor to figure out where the start and stop positions should be. We'll add in an on radio received block and then use a logic statement to say if the radio received number equals 1, what do we want our traffic signal to do? And if the radio received number equals 2, the second scenario that we want our traffic signal to do. For scenario number 1, that will be when the stop sign is raised, which means that pedestrians should be able to cross. In that case, we will have the traffic light signal turn to red and we will raise the pedestrian barrier so pedestrians can cross. In scenario number 2, which is when the stop sign is down or resting, we will have the traffic signal be green and the pedestrian barrier will be down. We'll download that code and then attach our microbit charge to our wrist to get ready to test. We'll test by raising our stop sign and then seeing how our project reacts. In this case, when we raise our stop sign, it is safe for pedestrians to cross, so the light goes red and the barrier is raised. And when we lower our stop sign, the barrier goes down and the light is green for traffic to flow through. You can find the machine learning data and the code for this project on our learning platform, along with many other projects just like this.